Okay, the next problem involves planetary orbit. I wanted to give you a little bit of vocabulary here so you know what we're talking about when we're given planetary orbit information. There's three specific things that they're going to be giving us, or I should say three things they can give us when we're talking about planetary orbit. First thing, assume every planet is positioned at 0, 0, and assume that it's horizontally positioned, just to create the same structure every time. Planetary orbits are elliptical, but they're pretty circular, pretty close to circular. The nice planets like Earth, okay? Other planets that are much more elliptical are going to be a little bit uglier, but just make them all horizontally positioned and all works out well. Comets also have elliptical orbits, but they're like way big elliptical orbits. So, but perihelion is the short distance on the path around the sun. Okay, so when the planet travels around the sun, and this is way long, okay, but the center of the orbit's here. The sun's actually pretty close to the center of the orbit for the most part. But the Earth's going to pass close to the sun. It's going to be further away from the sun at aphelion. Aphelion is the long one. So aphelion is from the sun to the Earth at its furthest point. Perihelion is the distance from the Earth to the sun at its nearest point. This, of course, is the sun. In case you didn't notice, the big yellow spot is the sun. All right. Earth is, or the planet we're dealing with, is on the black, the ellipse, okay? And the other thing we have is mean distance. And that's the distance from the center of the orbit to the edge of the orbit, either going to the furthest away or the closest point. And the sun itself sits on the focus. Okay, so the sun is on a focus of the ellipse. It doesn't move. Okay, it's stationary. All right, but it's on one of the two foci. It doesn't matter which one. I usually put on that one. Doesn't matter though. So if they give me a planetary orbit problem, I'm immediately going to draw this picture. I'm going to do a sun at a focus. I'm going to draw the orbit around like so, and I'm going to establish what they gave me, either perihelion, aphelion, or mean distance. Okay, mean distance in the sense of the ellipse equation is A. It's the distance from the center to the horizontal vertex of the ellipse. Okay? Aphelion plus perihelion divided by 2 makes that. So if they give me these two numbers, if I add them up, divide by 2, that's the mean distance. If they tell me the mean distance, I'm good. I've got A. Also, if I look at aphelion minus the mean distance, that equals C. Or the mean distance minus the perihelion distance is also equal to C. Take your pick. Right? Because if you take a look, here's aphelion, right? And there's the mean distance. What's left is C. Perihelion's distance from the focus to the vertex, that's the same as that, right? So if I take mean distance minus that, I'm left with the focal length. See the way you look at it? I've got C. And since we're doing a horizontally positioned ellipse, I know that C squared is equal to A squared minus B squared. So if they give us 2 out of these 3 things, we can very easily identify what A and C are. Then we can use this C squared equals A squared minus B squared to find out what B is. The center is going to be 0, 0. So our equation of the ellipse is going to be x squared over A squared plus y squared over B squared is equal to 1. So basically the technique here is, number 1, find the mean distance, A. Number 2, find C. And then once you've got A and C, use this formula to find B. And once you know A and B, you've got your equation. All right? Pretty straightforward as far as planetary orbit is concerned. It seems like it should be much more complicated than that, but that's all it is. So, Earth has a mean distance of 93 million miles. That means that A is equal to 93 million miles. I'm going to go with 93. Okay, just make a note in your answer that lengths are in millions of miles. All right. And a perihelion distance of 91.5 million miles. That means the closest we get to the sun is 91.5 million miles. That means the furthest away we get is 94.5 million miles from the sun. Okay. Find the equation for the Earth's orbit. So immediately I know it's this. X squared over 93 squared plus y squared over b squared equals 1. Before I go any further, I immediately know that much. Since they told me the mean distance, I immediately know that A is equal to 93. We're squaring that. And I also know that the value of C is going to be 93 minus 91.5, which is 1.5 million miles. I know that C squared is equal to A squared minus B squared. If I square things up, I get 1.5 squared is 2.25, I hope. 93 squared is some number I don't know off the top of my head, 8,649. So 2.25 is equal to 8,649 minus b squared. So the b squared goes to the left, the 2.25 goes to the right. So 8,646.75. All right, that's what b squared is. All right, I also have an a squared, right? So, going back here, here's my answer, just don't have b squared in it. So then I want to write my good answer. So x squared over 93 squared, I'm going to go with 8,649 plus y squared over 8,646.75 equals 1. And A and B are in millions of miles. Make an identification that your units are in millions of miles. Otherwise, you could do 93 million squared and whatever 8,646.75 square root as a million, and then squared would be, which I don't want to do that. Basically, I think add 12 zeros to each of them. So add 12 zeros to this, add actually 10 zeros when you move the decimal point 2 spaces over. If you want to put it just in regular miles, but I'd rather go with that. So that's all it is. That's all planetary orbit's going to be. They're going to give you 2 of the 3, aphelion, perihelion, mean distance. If they give you the mean distance, you're ready to go. If they give you perihelion and aphelion, average those to get the mean distance and you're ready to go. Once you know this and one of the 2, or even both, you can find the focal length. Once you know the focal length, you can find the missing B.